He's going to give us some lessons learned about multi-cloud, and his company works a lot in Kubernetes and making it really accessible and easy. So give a warm welcome.
Cool. So I'm Ethan Jackson. As mentioned, I'm the founder of Kelda. We're a startup that came out of UC Berkeley. And what I'm going to do, I'm not really going to pitch our company. I'm going to do sort of a general talk about where multi-cloud is today, why I think right now is the time that multi-cloud actually has the potential to work, and then what some of the disadvantages that this new architecture is starting presents. So it's going to be a slightly academic, technical talk. I will give you a little hint at what we do at the end if we have time, but yeah, so I'll just jump into it. So the high-level point that I think is really important to remember is that fundamentally multi-cloud is about vendor lock-in. There isn't really a technical reason why you would need to run a particular set of code on multiple cloud providers. It's all about more of an economic reason, which is that cloud providers want customers obviously stuck in just their cloud. Amazon doesn't want you to have the choice to use multiple cloud providers. And alternatively, cloud users want the ability to move between clouds primarily because they want to negotiate lower prices. You can kind of make an argument on the edge that some cloud providers have feature sets that differ from others, but fundamentally any of them will work. So I really believe that it's a negotiating issue. So multi-cloud is about vendor lock-in, and traditionally, and when I say traditionally, I mean for virtual machine-based monolithic programming. So before Kubernetes, before containers, before all of that. The primary battlefield of this vendor lock-in issue was the cloud API, right? So if you kind of do the thought experiment, if all of the cloud providers had the exact same API, and by the way, this was the original motivation for OpenStack way back in the day, moving from one cloud provider to another would be trivial. You just point at Google or point at Azure and you're over. The cloud providers have a vested interest in diverging their cloud APIs by having different features or just by totally arbitrary differences as a way to keep you stuck in their cloud. So the cloud providers want to keep their APIs different, and users, as represented by various open source projects and other vendors selling to users, have an interest in standardizing the cloud API, because the more similar cloud APIs are, the easier it is to move between cloud providers, if that makes sense. So there have been a bunch of projects that have kind of worked in this space. Apache libcloud was an early one. You've got Chef, Puppet, and Ansible, which aren't, they do other things, but partially they're about sort of standardizing the cloud API. And probably the most successful one is Terraform, which I'm sure a lot of people have heard of. And the way all of these projects work at some level is they build above the cloud provider API an abstraction layer. So I'll just talk about Terraform because it's the leader in this right now. You write your cloud API calls to Terraform, and then it has a translation layer down to Amazon's API or Azure's API or Google's API. And the goal is to sort of abstract away a lot of the sort of arbitrary differences between these cloud provider APIs. And this approach has helped a lot, but we've also kind of reached the limit of how much abstraction we're able to get. They do significantly reduce the totally arbitrary differences between different cloud vendors, which makes the task of multi-cloud easier. It makes it easier to move from one cloud provider to another. But they don't get all the way to sort of perfect cloud independence where I can run my app on Amazon one day, flip a switch, and then run it on Google or Azure on a different day. And the reason for that is that the underlying clouds that we're trying to abstract are just too different. If you're just booting a basic Linux VM, that is pretty easy to abstract with these tools, but the load balancers are different, the storage solutions are different. There's just so many sort of subtle and complex differences between cloud providers that trying to build an API abstraction layer on top of it isn't possible, and you're going to end up with something that's basically lowest common denominator. Okay, so that basically has been the state of the world up through just before the introduction of containers and microservices. And the argument I'd like to make in this talk is that containers and microservices fundamentally change the multi-cloud story and actually make it possible for the first time accidentally. Okay. So there's two general movements that I'm going to review really quickly, one slide each, and then talk about how they impact multi-cloud. Continuous deployment and microservices. Continuous deployment, just for those who don't know, is basically the idea that we should move from these extremely slow and painful multi-week manual release cycles to releasing code multiple times every day. And this is really pushed by the DevOps movement and sort of gained popularity over the past couple of years. And the key point I want to make about continuous deployment is that obviously if you're going to do multiple releases of your code daily, you're going to need a process that automates the deployment of that code. So doing manual processes isn't going to work, and automation becomes really important. Microservices. Netflix really kind of popularized the idea of doing microservices, and the basic idea here is for organizational reasons, we take monoliths, which are just big collections of code compiled into a single binary, and we break that up into a bunch of smaller programs, and those are going to interact together to deploy our application. And this provides some organizational benefits. Different teams can work independently without having to sort of block on this one choke point. The dark side of this is you go from one moving piece to tens or hundreds or thousands of different artifacts that you're going to deploy into production. And again, a manual process which would work if you're deploying one thing every 2 weeks does not work if you're deploying thousands of things every day. So both continuous deployment and microservices created massive pressure to standardize the stuff we're deploying. Because we have to automate getting this code into production, and building tools that automate deployment of totally non-standard things that are all totally different is just really, really difficult. So we got all this pressure to automate the things we're deploying, and standard tools emerge that do this. So we've got containers that came along, Docker being the most popular example of this, that automate the packaging and life cycle of the processes that are going to run in production. And then once you have containers, you can automate the sort of operational deployment of them, and you have Kubernetes and other container orchestrators that automate that. Okay. That was sort of a long digression. Bringing it back to multi-cloud, as I mentioned, the top-down multi-cloud approach that was based on abstracting the API, so think Terraform, is better than nothing, but not a complete success. CI/CD and microservices begin to gain popularity. And as an effect, we bottoms up standardized every piece of the stack all the way down to x86. x86 is the same everywhere, Linux is the same everywhere, Docker is the same everywhere, Kubernetes is the same everywhere. So now we have this extremely rich and powerful API for interacting with the cloud that is also portable, and that's Kubernetes. And in our experience, we have people that we work with on all different cloud providers. And as long as they're running a particular version of Kubernetes that we have validated that we work with, we can have confidence that our software will work for them. And it doesn't really matter if they're running on Amazon or Azure or Google, because sort of true cloud portability is finally possible. OK, cool. So that's the first high-level argument I'm making. Kubernetes is a great thing. We're not all the way there yet, obviously, but I think this is the path that's going to lead us to true multi-cloud. But like all things in computer science, it has downsides. And the specific downside that I want to talk about is that this new world of microservices and containers is a massive disservice for the actual developers writing code every day. The development experience has gotten a lot worse precisely because of the features of microservices and containers that made it possible for multi-cloud to develop. So that's what I'm going to spend the rest of the time talking about. OK, so the basic kind of high-level argument I want to make is that microservices result in a dramatic increase in complexity. A lot of that complexity is in production, where we have DevOps experts managing things, and we have really powerful tools for dealing with it. Because of this increase in complexity, we've standardized on these incredibly complex tools. Kubernetes is not easy. And it shouldn't be easy, because the thing it's managing is hard. So we have this increase in complexity, and we pair that with continued specialization of developers. So we're not in a world where every developer knows the entire stack from assembly up through front end. We're in a world where you have DevOps engineers who find Kubernetes easy, and you have front-end engineers who don't care about this stuff, all who have to be productive. And those sort of two things coming together, more complexity and less DevOps skills, result in a poor developer experience. So what do I mean by a good development process, just to get us all on the same page really quick? All developers, myself included, when I code, kind of go through this 4-stage process. Obviously, they'll jump back and forth between these stages, but they write code, they build their code into an artifact, they do some unit testing, they do some manual testing. And a development process is good if it's fast and efficient, so it's no slower than it needs to be. It's reasonably similar to production. We're obviously not going to give every developer a at-scale replica of production, but it shouldn't be gratuitously different, because developers need confidence that if their code works locally, it will likely work when it's running in production. And then it needs to be approachable. Oop, didn't mean to change slides. And by approachable, I mean that obviously the DevOps experts can be productive on the thing, but also front-end engineers, people who are new to programming, data scientists who don't have programming as a core task, all need to be able to be productive in it with a minimal amount of effort. OK. So monolithic VM-based local development actually hits these three categories. It works pretty well today. And that isn't an accident. It's a really difficult problem to build code and manage dependencies and all that sort of stuff. But we've been working on it for the past 50 years. So while the development process for C is terrible, and I know because I was a professional C programmer for 5 or 6 years, for Node.js, anyone can just sort of open up an IDE and click a button and they can go. Microservices change the developer experience enough to make it really poor. And the key thing that changed was how dependencies are managed. So in a monolith, all code has dependencies. If you're writing a piece of code, there's going to be other pieces of code it needs to run. In a monolith, those dependencies are software libraries. management of software libraries is a well-known difficult problem, but like I said, we've been working on it for a long time. So most languages, modern languages, have developed clear, well-defined specifications of what your dependencies are. We have semantic versioning now. We have tools for collecting those dependencies in a reproducible way on your laptop or in production. And for a lot of developers, they don't even really think about it anymore. It just works. Microservices obviously have software library dependencies just like a monolith, but they also depend on other microservices. You typically, in theory, maybe this should be possible, but most people we've talked to typically don't write their microservices in a way where it can just run on their laptop locally without access to any other microservices and work. And the tools for managing microservice dependencies are a disaster. Most companies we talk to don't know what their dependency graph among their microservices even is, right? There's not a good way for writing that graph down in a way that makes it easy for a developer to collect the dependencies they need. And the tools for booting collections of microservices are written by and for DevOps people. I'm thinking of Helm and Kubernetes YAML and Docker Compose. So, they may be easy enough if you're an expert in this space, but for the average front-end developer who's an expert in CSS but doesn't really care about containers, they're incredibly difficult to grok. And this really has an impact in the manual testing phase of the development pipeline. Code build and unit test is about the same as it was for Monolith. But because the microservice I'm working on depends on other services, when I actually want to get my code running on my laptop to test it, developers waste a lot of time doing that. It's very painful. So we've basically ended up in this world where manual testing of microservices doesn't hit our requirements for what a good development environment is. It's not fast and efficient. Even when you just look at CPU and memory usage, trying to run 10, 20, 30 microservices on a laptop really slows things down. Plus, the developers we've talked to report they waste 20 to 30% of their time fighting their local development environment, which sounds insane, but that's what they say. Also, the code test debug loop, so the time it takes between I've written my change and it's running so I can test it, has elongated. When I was running in Monolith, I built it and it was running on my laptop. Now I build it, then I have to build a container, then I have to get that container into some registry somewhere, and then I have to tell Kubernetes to reboot it. It's a big, painful process. We're no longer similar to production. Almost every company we've talked to runs Kubernetes in production and Docker Compose locally. Even though tools like Minikube exist, they are too difficult for most developers. So this causes all sorts of problems for obvious reasons. But basically, at a high level, it means that developers don't have confidence that the code that they're running locally is going to work in production. And then the core issue here is that it's just not approachable, except for developers who are experts in this stuff. OK. So the kind of state of the world that we have now, which is what we're hoping to fix at Kelda, is that every developer essentially has to be a DevOps engineer for their laptop. They have to manage a little mini production on their laptop. And this is not a big deal for people who go to KubeCon and follow this stuff and are excited about it. But most developers aren't like that. OK. So the good news is the problem is solvable. As I mentioned, the developer experience for C++ was terrible, but we made it better over time. And I don't see any reason why, without sort of consistent effort, we can't improve the experience for developing microservices as well. I have a little bit of time left, so I'm going to quickly talk about how we're kind of approaching this at Kelda. But I don't want this talk to be a long pitch of what we're doing. So if you're interested, check us out at kelda.io and you can learn more information. So since we started this company, we talked to maybe 150, 200 companies about how that they handle local development, and we found sort of two patterns. Most companies are struggling with this problem, which I just described. The elite tech companies, I'm talking about the ones, I'm not going to name any names, but the ones in San Francisco with giant budgets and nice cafeterias, they hire large teams to build out a development experience that's really smooth. So they solve this problem. And they all basically do it the same way, which is what we're trying to clone and make available to everyone. So what they do is they give every developer a personal development environment. So you kind of think of it as sandbox, where the developer just sits down and clicks a button, and they get a sandbox of all of the different dependencies of the particular code that they need is running. That sandbox often is running on in the cloud, not in a SaaS thing, but on the sort of user's infrastructure. In the case of Kelda, we run it on a Kubernetes cluster in your cloud. Those environments are managed and maintained by the DevOps team, but developers just click a button and they get it. They get it self-serve, basically magic. They centralize the configuration, so there's a central place that describes what all the microservices are, what all the dependencies are, and you get away from the world of every microservice having a Docker Compose file that's slightly different. They provide developers with a really clean command line interface that's extremely high level and allows you to do the easy stuff. In the case of Kelda, we have that coupled with the ability to drop down into Kubernetes if you want to, but the goal is for day-to-day work, you shouldn't have to do that. And then they allow for instant code synchronization. So instead of going through a full heavyweight build process, every time you want to test a change locally, they provide a mechanism where you can test a change and be going within 1 to 2 seconds, and then they save that sort of heavyweight build process for CI/CD. And obviously, we think that this approach meets all of our criteria. It dramatically increases the speed that developers can work at. For no other reason, removing stuff from developers' laptops speeds their laptops up, but also we increase the code test debug loop. Running on a shared Kubernetes cluster in the cloud is much more similar to production than running on Docker Compose locally, and it's a lot more approachable. So wrapping up, just to summarize the argument, monolithic development we've optimized over the past 50 years. Microservices had a bunch of good reasons to happen. But in the process of those good things occurring, we broke the local development experience, and it's going to require some significant effort to make it good again. So that's what we're attempting to solve at Kelda. Check us out at kelda.io, and obviously I'll answer questions, or feel free to email me or whatever. Yeah, cool, thanks. Yes.
Getting to know all of the people with microphones, because I'm always the guy who asks questions.
That's right.
If you had to compare yourself to, Draft or Scaffold or Garden, how would you do that?
Yeah, there's a bunch of tools going after that, going after this general space, which I actually think is a good thing. It's a real problem. A lot of it is a matter of sort of who we're going after. So Scaffold, for example, is developed at Google. It's very popular among the crowd that attends KubeCon. It's kind of an expert tool for experts. We're like really aiming at people who they know Java, but they don't even want to know what a container is, if that makes sense. So the problem that we're solving is the same, but then a lot of the specific choices around what the experience is like are pretty different. Yeah. Yep.
So like you mentioned, then I'm having that same personal problem. Is being an experienced Java developer for years.
Yeah.
Understood databases and technology, but in order to get my first microservice, I would have to learn Helm, Tiller, Kubernetes, Docker, everything, Spinnaker.
Right.
But so, are you proposing yet another layer on top, which I have to understand your syntax or script or whatever?
Actually, no. So the way our thing works, the DevOps team, what they have to do is sort of boot a Kubernetes cluster and manage it, which they already know how to do. And then our sort of key design principle is a developer should be able to use Kelda without really knowing that they're using Kelda. So you boot the IDE you're used to, you hit run, you open your browser, you go to localhost, there's the code running. The fact that it's running in a container, on a cloud, in Kubernetes, like you shouldn't have to know that. Now, if you want to dig under the covers, like you can. But a key sort of design philosophy is that the development experience should be as similar as possible to how it used to be.
So follow up on that. So the developer is hitting run and it's getting deployed, but
Yeah.
someone is maintaining that configuration.
Yes.
So that's the DevOps people will
Yep.
provide that configuration.
Yeah. And by the way, that configuration is basically the exact same as what's running in production. Like you still fundamentally have to maintain a list of everything that's running and where it is. And one of the things that we're planning to add is the ability to just pull that automatically from other sources, so it's not a kind of manual process.
So basically, your process will combine the Helm charts and the Spinnaker pipelines and all that.
Yeah, it'll hide that from the developers. Yeah, yeah. Cool.
Anyone else?
Cool. Well, I'll stick around outside after too if anyone has questions that they want to ask. Thanks.
I just want to say thank you to everybody for coming to Escape 19. On behalf of Cockroach Labs, this has been a wonderful 2 days. First conferences are difficult, so we're welcome to feedback, to hear some feedback, and we're excited for next year already. Thank you guys so much. We appreciate it. So thank you. And Ethan, a big thank you from Jim. So.